The question we are solving now belongs to test series 6. It is of network theory subject. In specific, it belongs to sinusoidal steady state analysis. As per the question, there is a AC circuit as shown in the figure. It contains a voltage source at a voltage of 5 at a phase of 0 degrees, which is connected in series with a 1 ohm resistor. The network contains also a magnetically coupled coil as shown in the figure, and the circuit contains a 2 farad capacitor as well. The magnetically coupled coil has two inductors, each of them are of inductances 3 Henry, and the dot convention of the inductors is as shown in the figure. The mutual inductance between the coils is 1 Henry. We need to find the frequency omega in radians per second at which the circuit shown will be under resonance. From the given circuit, we see that if we assume mesh currents I1 and I2 in the given circuit, we see that by applying KVL to each of the meshes, we can get the equations as 1 multiplied by phasor I1, that is the drop across the 1 ohm resistor, plus j omega 3 multiplied by phase of I1 minus I2, that is the drop across the 3 Henry inductor due to self-inductance, minus j omega I2. Please note that the term minus j omega I2 corresponds to the mutual inductance. This should be equal to 5 at a phase of 0 degrees volts. Please note that here we have put a negative sign due to the reason that the current I2 is entering the dotted terminal of the 3 Henry inductor. So the voltage due to mutual inductance will be sensed positive at the dotted terminal of the coil being marked. Because of this reason, this is a rise, hence there is a negative sign that is coming into picture here. Similarly, upon applying KVL to the second mesh, we see that the equation corresponding to the second mesh can be written as j omega 3 times I2 plus 1 by j omega 2 times I2 plus j omega 3 times I2 minus I1. Please note that j omega 3 I2 and j omega 3 times I2 minus I1 are drops corresponding to the self-inductance. Now let us put the terms corresponding to the mutual inductance, which can be written as j omega times I2 minus I1 plus j omega I2, that is equal to 0. Upon simplifying this, we see that I2 can be written as I2 phasor is equal to I1 phasor multiplied by 8 omega square divided by 16 omega square minus 1. And we also know that ZS can be written as, that is the ZS is the impedance as seen from the source, that is equal to 5 at a phase of 0 degrees divided by I1. Upon substituting for I2 in the equation 1, we see that upon equating the imaginary part of the source impedance to 0, we get that the angular frequency is root 3 by 4 radians per second. That is, when angular frequency is root 3 by 4 radians per second, the impedance as seen from the source is 0, and in this case the circuit will be under resonance. Hence, the correct angular frequency for which the circuit will be under resonance is A.